We're on to question 3. So question 3 is a calculus question. It's a good kind of learning here about exam technique. You might well recognize the first part and say, oh yeah, product rule differentiation. I know how to do that. But you have to look at part B and C. This is quite a long question, much longer than question 1, particularly longer than some of the other ones as well. So you got to make sure that you can do part A, B, and C if you're going to do this question. So, you know, it's certainly one I would imagine people wouldn't be starting with this question. But anyway, let's have a look at part A, which hopefully would be straightforward enough for people. It's product rule because, you know, the two parts are being multiplied together. So U is equal to X, V is equal to E to the power minus X. I differentiate the first part, du dx is 1. I differentiate the e to the power minus x. It's e to the power minus x, right? Because when you're differentiating e to the power of x, it would remain as e to the power of x. But because it's got a minus, it's chain rule. I must multiply by the derivative of minus x, which is minus 1. So I get minus e to the power minus x, or you could say if you wanted minus 1 times e to the power minus x. Okay, we know our product rule. dy dx is u times dv dx plus v times du dx. The first times the derivative of the second plus the second times the derivative of the first. So dy dx is x times minus e to the power minus x plus e to the power minus x times 1. Okay, so again, it's the first times the derivative of the second plus the second times the derivative of the first. We tidy it up. If you wanted, you could factorize out the e to the power minus x and you'd have 1 minus x inside there. And either way, you get 5 marks. Okay, so you've started. The second part is trickier. It says that we have to integrate, and it says hence show that the integral of x times e to the power minus x dx is equal to all this bit here on the right. Now, there's a trick here that you learn. You'll see it here, and you'll see that it has come up before in the leave insert, and it's come up before in pre-exam. So as you practice more towards the exam, you'll see that this trick gets used and you will learn it. Okay, the first time you see it, it can be difficult to understand. You'd say like, God, how would you know to do that? But it is something you just practice and you get used to. So what we know is this, right? We know that differentiation and integration are connected. So, you know, if you reverse integration, you get back to what you differentiated. It's like an inverse function, except of course, we know you have to add on the plus c, the constant of integration. So we started up here with y is equal to x times e to the power minus x. We got e to the power minus x minus x times e to the power minus x when we differentiated. So this part down here, if we integrate it, we get back up to here, but we'll also have a plus c. Okay, so that's what we're doing there. Now we know, looking at what we need to do here, let me just change pen color to make it clearer. We know this is what we're asked to integrate, right? So we have that part inside here, right? But we have an extra bit added on that we don't really need. We don't really want this guy over here. He's stuck in there. Now we will remember, I hope, I'm just making this example up, right? If you had x cubed plus x squared dx, I hope you know that we can split up that polynomial and integrate each part separately with respect to x. So you'd end up at x to the power of 4 over 4 plus c plus x to the power of 3 over 3 plus c. But you can just put those, like that could be c1 and c2, you know, because they're two constants of integration. But what we actually do is we just call it plus c, the combined one, okay, because c could be anything. So now, taking that into account, that's exactly what we're going to do here. We're going to split up this first part. So we're going to integrate e to the power minus x dx. And we're going to integrate so you can see we have our minus outside of here, but our x times e to the power minus x dx. Now, the right-hand side is still going to be equal to what we have there. Now, we know this is our key bit. Okay, so what I'm going to do is I'm going to bring that over. I'm going to isolate that by itself on the right-hand side. So I've just brought it over. So it was a minus over here. So I'm adding the integral to both sides. And I'm bringing the rest of it over here. So x times e to the power minus x becomes minus x times e to the power minus x. And you could say, well, what happened about that plus c? Surely that plus c should be a minus c over here. But again, it doesn't matter. It's just a constant of integration. It could be anything. You know? Remember, if we differentiated it, it would disappear. So now, right, remember, this is what we're still working towards here, getting this, okay? So our only last task is to integrate this guy, okay? So we're going to integrate him. The integral of e to the power of x, the e to the power of x dx will just be e to the power of x, right? But e to the power of minus x dx, when I'm integrating that, it still says as e to the power of minus x, but I divide by the coefficient on the power, and I divide by the derivative of that coefficient, which will be minus 1. So that's why we end up with a negative answer here. Again, you could have a minus 1 there if you want. So what's going to happen here is, right, I'm just going to, you know, if I write this out, I'm going to have this, right? When I integrate this part here, I'm going to have, let me just clear all this off. When I integrate that, I'm going to minus e to the power of minus x. I'm going to still have my minus x times e to the power of minus x. I'm going to still have my plus c, and that's going to be equal to x, the integral of x times e to the power minus x dx. I look up here, that's exactly what we want, isn't it? And then I'm just going to write it in the way that's given in the question. So I'm going to say, therefore, the integral of x times e to the power minus x dx is equal to minus e to the power minus x times e to the power minus x plus c. So rearranging it just to look exactly like what we have in the above, we do that in the last line and we get 5 marks. So there's quite a lot of work for that 5 marks, I must admit. So you breathe a sigh of relief and say, okay, we got there. And then you look over the next part, and there's a bit of work to do here too. It says the graph of y equals f of x, where f of x is x times e to the power minus x is shown below. So this is the graph of that function. An estimate is required for the area bounded by the function, the x-axis, and the vertical lines x equals 1 and x equals 5. Two rectangles, each 2 units wide, right? So 2 units wide, okay, have been added to the graph to be used in the calculation of an overestimate of this area. So an estimate, but it will be an overestimate. Calculate this overestimate by finding the sum of the areas of the 2 rectangles correct to 3 decimal places. Now you might think, okay, am I to calculate how much it's overestimated by? You know, and you definitely should read the question a few times. But in fact, it does give you direction here of what to do. Finding the sum of the areas of the 2 rectangles correct to 3 decimal places. That is your task here. So, okay, so you can see that the width in both cases is 2. How do we find the area of a rectangle? Length by width, or the way it looks here, width by height. So we got to find these heights. So how are we going to find the height? Well, we're going to put in 1 for x to find this one. I'm going to put in 3 for x to find that one. So we put in 1, and okay, it works out easy enough. It's going to be 1 times e to the power minus 1, which is 1 over e. Now you can obviously calculate that. And then that will, once you multiply that by 2, you will get that area, okay, because it's 2 units wide. So you will end up with 2 over e. You put in 3 to get this next height here now. You're going to put in 3 for x, 3 times x to the power of minus 3. So it's going to be 3 over e to the power of 3. To get the area, it's going to be multiplied by 2, because that's the width, length by width, or width by height. So you're going to end up at 6 all over e to the power of 3. So your total area, we want to correct it 3 decimal places, but as a kind of definite correct answer, it'd be 2 over e plus 6 over e cubed. Add them together and you get 1.03448,129. Correct to 3 decimal places. 1.03448,129. and it is unit squared. And do remember to add in the unit squared because you are talking about an area. Okay, so we've done that. 5 marks for that. Let's keep going. It says in this case for part 2, well, we're going to try and get a better estimate. It will still be an overestimate because we're going to be, you can see our rectangles are above the curve. But in this case, we're going to get 4 rectangles, so each of width 1, okay? Because it's just going to be 1 unit wide in each case. So in this case now, we're going to have to get 4 heights. So we're going to go 1, 2, 3, and there'll be another one here, 4. So we put in 1, and again we get the height of 1 over e, and you could say 1 over e to the power of 1 if you wanted. So we're going to get 1 over e. We put in 2. So, you know, it's again, just to be clear, you're putting them into this function up here. So you get 2 times e to the power of minus 2. So that'll be 2 over e squared. Okay, and the area is going to be 2 over e squared multiplied by 1. So 2 all over e squared. Similarly, it's going to work the same then for 3. It's going to be 3 over e cubed multiplied by 1. Okay, so it'll be 3 over e cubed. And then 4 over e to the power of minus 4. So 4 over e to the power of minus 4. So that'll be 4 over e to the power of 4 multiplied by 1. And that's equal to 4 over e to the power of 4. Okay, so that is my 4 areas. You can see this will be a lesser overestimate because it doesn't have those 2 little rectangles there in white. So when we work it all out, we get an answer. Again, we want our answer correct to 3 decimal places. So we're going to get an answer. I think we were 1.014 or something like last time. So now we're down to 0.861 units squared. So we can see the area is getting smaller as we take more rectangles. And there's 10 marks for that. And as we would do more, if we split it into widths of a half a unit rather than 1 unit, it would get smaller again. Okay. But what we know, of course, is that what actually integration does is it gets you the exact area under the curve. So it would not give you an estimate, but the exact area between the curve, the x-axis, and in this case, the line x equals 1 and x equals 5. So these are our limits. So we're talking now a definite integral. We know that when we integrate the function x times e to the power minus x dx, we get x times e to the power of minus x minus e to the power minus x. And our limits now are going to be 5 and 1. You might say, well, what happened to plus c? So you might say, where do you go to the plus c? Well, when we have the definite integral, we don't need the plus c because we know he's going to cancel out when we put in our limits of 5 and 1. So when we put in our 5, you know, we're putting in our 5 here for x as our upper limit. That's giving me this section. I'm going to subtract my lower limit by putting in the 1. So I'm going to be putting in 1 for x into the 3 spots. And that's going to give me this part. And at this stage, I'm looking to get this correct to 3 decimal places. So, okay, there it is as a fully correct answer. But I'm sure some of you will just put it into the calculator from there. However, do write down that line because if the incorrect answer with no workings would get no marks. So you do need to get the correct answer. Corrected 3 decimal places, it turns out to be 0.695 units squared. Okay. So we then had to answer this last question. Compare your overestimate calculations from B with your answers to part C. Comment on the effect that increasing the number of rectangles used in your calculations has on the accuracy of the answers obtained. So we could see that when we had 2 rectangles, we were at like 1 point, I think it was 0.14. When we had the 2 rectangles, or when we had the 4 rectangles, I should say, we had 0.861. And so our fully correct answer was 0.695. So basically, as the number of rectangles increases, the estimated area becomes more accurate, gets closer and closer to the actual area. So you could see with that question, there was a lot to it. There was a lot to it. You had to have a good deal of understanding to be able to do all those parts. So the lesson is, don't just look at part A and say, oh yeah, I can do that. You got to look at the full question before choosing to do it. Okay, let's go on to question 4, which will be complex numbers.